Okay, so we're back. Since our lunch is late, we're gonna keep talking about more topics. So the next coming up is render functions. Okay, so we talked about reactivity in the first section, and now we're talking about render functions. And render functions are essentially the other half of the puzzle that completes the whole reactivity rendering system in Vue itself. And in case you don't know, render functions are, Vue templates are in fact compiled into render functions under the hood. And since not everyone has used React, we're gonna share some, I guess, basic knowledge. So in a Vue context, when we first render a Vue app, we will first compile the template into render functions. So this compilation process happens on the fly if you are using the full build and you're directly, say, using an in-DOM template, like you're writing the template directly in the DOM, or you're giving the Vue instance a string of templates. But if you're using Vue CLI to scaffold a project with the build step, so with Webpack and Vue Loader actually pre-compiles the template at build time. So the code you ship to the browser doesn't contain the original template. Instead, it ships the compiled render function code, which is pure JavaScript. So this is sort of similar to the ALT compilation in Angular context, in that it saves the runtime cost of actually doing the compilation on the fly. And also, we can ship the runtime without the compiler. So in Vue, we have two builds. We have the full build, which includes a compiler, which is close to 30 kb zipped. But if you throw away the compiler, the runtime only build is 20 kb. So that's like a third size saving, which is pretty good if you're using ahead of time compilation. Okay. So after compiled into render functions, and what render functions are essentially functions that return virtual DOM, right? And then Vue generates the actual DOM based on the virtual DOM. And then we're going to talk a bit about what virtual DOM is. But before we do that, so on subsequent updates, so notice that the initial render is what happens if you're going back to the autorun function that we implemented earlier. This is what happens inside the autorun function. Okay? And after this process, during the process that we generating the virtual DOM, essentially calling the render function, because the render function depends on all these data properties on your Vue instances, and these data properties are reactive, all of these data properties are collected as dependencies of this component's render function. And now, if any of those dependencies change, what happens is the render function will be called again, all right? And on subsequent updates, the render function gets called again, and it'll return a new virtual DOM. And the old virtual DOM and the new virtual DOM will be compared and diffed. And eventually, it'll be applied, we apply the minimal amount of changes to the actual DOM. So what is the virtual DOM anyway? So the actual DOM, most of us know the native DOM API, for example, document.createElement. We can create a real div node that represents this div in our actual document. So this is native API. And its internals are in fact implemented in like C++ by the browser engine. We don't actually get to touch most of it. Like it just exposes the API in JavaScript for us to work with it. In comparison to virtual DOM in Vue, we have this, on each instance there's actually this $createElement function, which returns a virtual node that also represents a div, but it's just pure JavaScript. It's just an object. The difference is actually pretty huge because, as you know, if you log a div's properties inside the browser, you'll see that a real div node have so many properties, and the underlying implementation is in fact pretty heavy. And also because we are essentially calling these native code via a JavaScript interface, there is this cost of communication between the two sides, and it's going to be more expensive than, say, doing pure JavaScript operations in pure JavaScript land. So this is why a lot of times we say if you touch the DOM, things get slower. In some browsers, they might optimize that, but in general, there is this slight overhead when you're reaching to native stuff from the JavaScript side. So as you can see, the virtual DOM div is just an object. It has a tag that tells us it's a div. It has a data object, which contains the attributes, possible attributes. If it doesn't have any attributes, it doesn't even need to have a data object. And then it can have a list of children, which is an array of more virtual nodes. So now we have a tree of virtual nodes, which constitute the virtual DOM. So this is just very high-level understanding. Virtual DOM is cheaper than the actual DOM, right? So let's say we have a list of like 1,000 elements. Creating 1,000 JavaScript objects is pretty cheap. It's pretty fast as well. But creating 1,000 actual div nodes is much, much more expensive. Okay. So this virtual DOM is essentially a lightweight JavaScript data format to represent what the actual DOM should look like at a given point in time. This is important because we're generating copies of virtual DOM on every update. This is only made possible because virtual DOM is cheaper than real DOM nodes. If we, say, use inner HTML to update our app, we're essentially throwing away all the previous DOM nodes, real DOM nodes, regenerating all the real DOM nodes again. So this cost is much, much more expensive than, say, just generating a new virtual DOM snapshot. And inner HTML also has a problem. It throws away the current state on, say, like form input elements and all that stuff. So, but a common misunderstanding is virtual DOM is what makes a lot of these frameworks fast. It is not. Virtual DOM is just a way to get around the limitations of the original DOM so that it enables this paradigm of declaratively composing what you want the DOM to look like. So this unlocks a bunch of possibilities. But there's also this, comparison between, well, I'll talk about it later. So another benefit of the virtual DOM is that it decouples rendering logic from the actual DOM. Right? So our app, so we have the steps of diffing, then we apply those changes to the DOM. If we throw away the last step, all of our app's updating logic can actually be executed virtually. It doesn't need to ever touch the DOM. And in fact, if we abstract out these eventual connecting points, the APIs that touch the DOM, and then sort of redirect them to other places, we can create the same app running virtually in any environment that supports JavaScript, but it doesn't necessarily have to touch the DOM. Instead, it can talk to a native rendering engine. For example, on iOS or Android, or on the server side, we can turn the virtual DOM tree into strings by stringifying them. Making the virtual DOM talk to a native renderer instead is what enables projects like React Native, Wix, NativeScript. They all have this similar architecture where your JavaScript app runs virtually inside an embedded JavaScript engine, and it only sends the necessary messages about after, say, diffing or the actual node operations sent to the renderer side. So this is the architectural advantage of virtual DOM. Obviously, virtual DOM is not the only way to achieve that, but it's a pretty good way to do that. And render function, finally, it's just a function that returns virtual DOM. Okay, so templates in Vue.js are compiled into render functions by the compiler. So we have a little app called Vue Template Explorer, which you can use to sort of get you can explore how the templates are compiled into render functions. But we'll talk about what render functions actually look like in more details later. So putting everything together, this is putting the render function side and our reactivity lessons together. Each component has a render function, and this render function, when we run it, it's essentially wrapped inside an auto run that we implemented earlier. So that's why when it renders, we're collecting all these dependencies by invoking these getters on our data properties. And then we have this additional concept called a watcher. That's each component has a watcher that's responsible for collecting dependencies, cleaning them up, and notifying everything. And the component render function returns virtual DOM. So you see the loop here, because we're inside auto run when we render, the render will be called over and over again whenever the properties that we depend on during the render changes. So each component has this sort of its own auto run loop. And a component tree consists of many of these components, each with their own dependency tracking, each as a dependency boundary. So each component tracks its own dependencies. So this is, in fact, an advantage when you have a huge component tree, because you can have the data dependencies change. Your data may be mutated from anywhere, but because each component tracks its own dependencies, inside a big component tree, we precisely know which components are affected by arbitrary data manipulation. So we never over-render. We don't have the problem of having too many components being re-rendered unnecessarily, because we have a precise dependency tracking system in place. So that's an architectural advantage that gets rid of some sort of optimization efforts that you need to do in a more top-down based rendering model that React uses. But we also pay the overhead of converting these data into getters and setters. Right? This has a slight overhead as well. So it's not like a silver bullet. There's like pros and cons on both sides. And but in general, both approaches are viable, and they're, people have built huge apps in both React and Vue. So in practice, the difference would only show up in very extreme cases. So render functions, we're finally getting into it. Before we talk about render functions, so there is this sort of competing schools of thought in front-end community about JSX render functions versus templates. People who like templates hate JSX. People who like JSX hate templates. And in my opinion, they are pretty much the same thing. Templates, so because when we talk about these things, we need to think about their end goals. Both JSX and templates are a way of declaring the relationship between the DOM and our state. Template is just a more static, a more constraining form of expression. And that static property has its advantages. So template is more static. JSX or render functions are more dynamic. Being more dynamic gives you advantage of full access to the programming language. You can do anything you want. As long as you can write it in code, you can do it in a render function. So that kind of gets rid of the need for inventing new syntax in templates in order for you to achieve some esoteric rendering requirements. On the other side, templates are more static. In fact, Vue templates are syntax-wise, they're parsable by any HTML parser. So that allows you to quickly migrate existing templates or migrating existing design, say, markups produced by designers. You can quickly adopt them into your code, better familiarity, and more importantly, the static nature of templates allowing better compile time optimizations. The dynamic nature of JSX actually makes optimization much more difficult because there are less assumptions that can be made. Because templates are constraining, these constraints actually serves benefits when you're trying to compile them, because you know that you can only write the template this way, so you can assume a lot of things, so you can do more optimizations at the compile time. So there are benefits on both sides. But eventually, Vue supports both because we see benefits on both sides. So we expose templates as the default API, but we also allow you to drop down to the render function layer when you actually need that level of flexibility. It's just we don't use it as the default. OK, so render functions. This is a Vue component. And instead of giving it a template, you give it a render function. Pretty straightforward. So the render function takes a single argument, h. So this is an alias for create element. H is just a convention because there are a lot of different implementations of virtual DOM, and they sort of have agreed on a common API called hyperscript, which is a style of writing these virtual DOM render functions. And because hyperscript is like HTML is like hypertext transfer protocol, and so hyperscript is a script that produces hypertext, and eventually it gets shortened to H because it's easy to type. It's just a convention. Okay, so it takes 3 arguments. The first argument is the type of the element, very obvious. The second is a data object. The data object can contain, so nested under it. So in React, this is directly the props object, but in Vue, we nest more fields under this object. So props, ATTRs, DOM props can each be nested in different objects, and class and style are also get special treatment because they are so commonly used, and they have we have some special convenience support for class and style. So for example, in templates, you can bind to class using an array or an object. You can do that the same in render functions. The API is the same. And eventually, the third argument is just an array of more child nodes. So you will nest H calls inside this array to produce more child nodes. So everything is just nested calls. Eventually, together, they return a tree of virtual nodes. And it's pretty versatile, too. Notice that the second data object is optional. If you don't have any data for this node, this is just a bare div node, you can omit the second object and directly give it to children. And the children argument is also pretty flexible. It can be an array, or you can just directly give it some text. It'll automatically convert this text into a children array of virtual text nodes. So the first line here creates a div with some text inside of it. The second one creates the same div, except it has a class of foo. And the third one creates a div with some real children. So you can have some text inside the children array alongside with another virtual child node, which is a span. So this would create something like div, some text, span, bar. So there's if you search for render functions in the API docs, you'll see more details. But this should get you through most of the basic use cases. Any questions so far?
So anytime you would have like text, that would just be like the actual text inside of there.
Yep.
If it was a child that had like an object, that would be an actual HTML element.
Yeah. So you need to create it with the H function.
Gotcha.
Yep. And remember, inside your render function, you would need to eventually return this top level element so that the whole tree gets returned. And a relatively lesser known feature of the H function is that it can directly render a component as well. Similar to how we use custom elements as custom components as custom element tags inside our templates, the H, in addition to taking string tag types, it can also directly take a component definition. So let's say we import a component from another Vue component file. And you can directly pass that component into the H function. So that'll create a component instance. That'll create a V node representing that component instead of a normal element. And you can then pass the props to that component in the data object as well. So this is a lesser known feature. So basically this means you no longer have to register the component inside the components option, then reference it using the kebab case name of it. You can completely skip that step when you're using render functions.
There's some questions in chat. I'm not sure when you want to address them.
Sure, I can take questions now.
Okay, so do you know any major production sites that pre-compile their templates?
I think almost all major production sites built with Vue are pre-compiling the templates. Because you will be using Webpack and Vue Loader, and if you're using that, you're already pre-compiling by default. Yeah.
What do you think about templates for functional components?
That's something we are planning to support, but there are some edge cases that we need to carefully evaluate because functional components do not support everything that stateful components support. But internally, we have an experimental branch by Blake, who's on our team, and he's done an experimental branch that already sort of got it working. It's just we have to iron out some edge cases to make sure like everything works smoothly as expected.
Can you ask whether the the render function is different than the render object inside a view instance? Usually seen when I create an app via view CLI.
The render object?
When you create an app, I can kind of help rephrase it because I've seen it. When you create an app with Vue CLI at the top level,
Right.
in the Vue instance, there's a render and then H
Returns app,
and
right?
H app,
Yeah.
I
So
think
that's
exactly
just
what you
using,
described.
yeah, that's just using the, so that's a render function, and it's just using the arrow function shorthand. Instead of doing the full render return, it's just directly returning another component. So this is also a very common pattern, which we will in fact talk about later, that a component can return another component as its own root node, right? So this outer component doesn't render anything of its own. Instead, it simply renders another component. So this is like a shell component, but this shell component can do some interesting things. And in the case of the root instance in the Vue CLI template, we let the root instance, we want to separate the responsibility of the root instance because we do inject stores, routers at the root level. And also, the root instance cannot be hot reloaded. That's a technical limitation. So by separating the root instance with your app component, that allows our app component to be hot reloadable. So when you edit the app.vue file, you will see hot reloads. But if you edit the root instance itself, then you have to manually reload your page. So that's just also a development experience concern. All right, so okay, let's move on. So we talked enough about render functions. Time to get our hands dirty and do some exercises. So let's open our repository again and going to 3.1. Oh, I think I'm in the solutions branch. Wait. I'm gonna save this. Okay. So 3.1 says implement the example component, which given the following usage, so obviously it takes a tags prop, and the tags prop takes an array of h1, h2, h3, array of strings, tag names, right? And then this component, when it's rendered, it should produce the following markup. It should just render these tags, and inside each tag, it should be the index of that element in the array. So imagine how to do this in templates, right? How would you do this in templates? Right? We don't really have, so by default, we don't really have a construct that allows you to say dynamically render this tag here using this data source, right? So in Vue, we have this construct called component is. This is the closest thing to it, because component is just an abstract placeholder. What it really renders is determined by this is. So if you do component is h1, this works as well, right? But the original intention of this API is really just to allow you to dynamically switch between components instead of rendering real tags. And you are only able to do this with templates because we provided this API to you, right? So the important thing to note here is if we didn't provide this API, then there's no way for you to achieve what you're trying to do here with just templates. So we come to an interesting disadvantage of the template is that we have to come up with a lot of these syntax APIs in order to solve some use cases. But when you run into a case that it's not supported by the template, the only thing you can do is really go and open a feature request on GitHub and wait for us to implement it, which is not optimal if your manager is waiting for the app to ship in the next week or something, right? But with render functions, we can just solve that with JavaScript. So the exercise really is implement this example component with render functions that achieves this goal. And you can look up the render function usage in the docs or from the slides. And yeah, let's work on this for 10 minutes.